Okay, let's go for the OSPF lab. In this case, we're going to use OSPF version 3. We are going to configure the global routing table for management. And this device, we are going to use the global routing table in order to advertise the loopback IP address of every single device. And in this case, in the case of this device, we're going to use an SBI for VLAN 10. Remember that we have this SBI here and this SBI here for VLAN 10. We are going to make these two SBIs participate in OSPF, where we are going to configure them as passive interfaces. Notice that in this case, we are using these sub-interfaces to create the neighborships for the global routing table, because we are using data path virtualization for VRF Lite. Notice that in this case, we are not using that. We are not using 802.1q in order to create data path virtualization, because the data path virtualization in this part of the network will be performed by Lisp. In this case, OSPF version 3 will serve as the underlay for Lisp. Now, for the VRF users, we are going to configure this as an address family for the IPv4 and IPv6 for the VRF users. Here, and here. And notice that we are going to use these 802.1q sub-interfaces because we are using data path virtualization in order to communicate the VRF users. Notice that in these interfaces, we are not using data path virtualization using 802.1q for the VRF users, because Lisp is going to be in charge of doing that. Now, for the VLAN 100 and VLAN 101, we have an SBI here, a couple of SBIs here, and we are going to configure those SBIs as passive interfaces. Now, for the VRF guest, we are going to configure the VRF guest and address family IPv4 for the VRF here, and for the VLAN 102, we have an SBI here and an SBI here. We're going to configure this SBI as passive. Notice that we are using these sub-interfaces using 802.1q for data path virtualization in order to create neighborships and separate neighborships for the VRF guests. Notice that given we're using OSPF version 3, we need to enable IPv6 everywhere. We need to enable IPv6 in this subinterface, in this subinterface, in this subinterface, in all of these subinterfaces, subinterface, in this loopback, in this subinterface, in this subinterface, in this loopback, everywhere. We need IPv6 everywhere because we are running OSPF version 3. Now notice that this link here is going to be a backup link. And this link here is going to be also be a backup link, as well as this link here will be a backup link. So we will need to modify the cost for OSPF. We are going to set a cost of 1,000, and this here, and this interface here, and this interface here, and this interface here. We are also going to set up our areas. This will be my area 0. This will be my backbone. This router and this router will become area border routers. We are going to have this as the area number 4, and we are going to have this as our area number 5. Notice that area number 5 is not directly connected to the backbone. That is a design error, so we'll have to fix it. So we're going to have to set up a virtual link here and a virtual link here. So notice that for virtual links can only be created in IPv6 address family, so that can become a problem in production. So let's go for the lab. Okay, first we're going to configure enable IPv6 routing, and then we are going to configure OSPF version 3 with the adequate address families. So enabling IPv6, then we are going to set up the address family for the global routing table, then 2 address families for the VRF users, the IPv4 address family and the IPv6 address family, and then the address family for the VRF guest. Then we are going to make the interfaces of this router participate in OSPF version 3, depending on the BRF where these interfaces are attached to. They will be accommodated in the adequate address family. So remember that if we issue show IP BRF, these interfaces belong to the BRF guest. These interfaces belong to the BRF user. So when enabling OSPF version 3 at each interface will be accommodated in the adequate address family. So let's do that. Let's configure or relate the interfaces to OSPF version 3 so they can participate in the routing protocol. Okay, notice that per interface we are enabling IPv6. We have to do this at every single interface because OSPF version 3 works with IPv6 link local addresses. And depending on the interface, we are going to add this to the IPv4 address family. For the users interfaces, we are going to add them to both IPv4 and IPv6 addresses. And we are going to set up point-to-point networks because we want to avoid having too many broadcast networks, and at the same time we will avoid having to elect designated routers per every single neighboring session or network connection. Okay, we're going to do the same at each device. Okay, let's go for router 2, and we are going to configure the same. We are going to enable IPv6, set up OSPF, and then we are going to enable or make all the interfaces participate in OSPF version 3. Let's do that here as well. Notice that given we are working with switches now, and most of the interfaces will be SBIs. Okay, IPv6 unicast routing, then the address families, then we are enabling or making the interfaces participate in OSPF version 3. We have to enable IPv6 at each interface, and we are using network point-to-point to avoid having to elect a designated router on each connection because we're using 1 gigabit per second connections. So OSPF will try to set this connection as network, as broadcast connections. So we don't want that. And this, finally, we are enabling this OSPF version 3 for the SBIs that belong to the VLANs of users and guests and management. So let's go for switch 4 and do the same. Okay, for switch 4, we're going to do the same, enable an IPv6 routing, set up the address families, and then we are going to make the interfaces participate in OSPF version 3. We are going to enable IPv6 at each interface because we need link local addresses, and we are setting up the network type to point-to-point because by default it is going to be broadcast, and we don't have to go into elect a designated router but for these connections because these connections are point-to-point. We only have 2 devices per connection. We are going to make the SBIs participate into OSPF version 3 as well. And remember that we have to make these SBIs for VLAN 10, VLAN 100, and VLAN 101 and VLAN 102 as passive interfaces. So let's configure these SBIs as passive. So we have to go into router mode and configure per address family what interfaces will be passive. So for the global routing table, the VLAN SBI VLAN 10 will be the passive interface. For the VRF users, we will have these 2 SBIs. For the IPv4 and for IPv6, only VLAN 100. And for the VRF guest, this will be passive. Now let's do that here as well. Okay, so we have our SBIs that belong to the VLANs that are facing my layer 2 part of the network set as passive. We are going to configure now certain interfaces as backup. Remember that we are going to set up here this connection that goes from router A1 to switch 4. This one will be a backup link. This one will be a backup link. And this will be a backup link. So we're going to set up costs in those interfaces and sub-interfaces. So let's do that. So these three sub-interfaces that belong to gigabit 40 will have a cost of 100. So let's go for router A2 and do the same. Okay, let me fix that. Okay, notice that we are affecting two interfaces, 50 and 30, that corresponds to this link and this link. So let's go to switch 3 and modify the cost for these subinterfaces that belong to this link. Okay, let's go now for switch 4. Okay, now let's go for router C1. We have to configure that in this link, gigabit 6. So RC1, let's configure all of it. Let's go and configure OSPFv version 3 and do the cost as well. So what we're doing here is, as all the other devices, we are setting up OSPF version 3, enabling IPv6 routing before, then OSPF version 3, and address family for the global routing table, and address family for the VRF users. And in the case we're not you're going to use guest, notice that in these cases for certain devices, for instance, iOS XE and more recent iOSs, we have to enable this capability VRF Lite for OSPF, and then we are going to make the interfaces participate in OSPF version 3, and finally we are setting up the cost. Okay, let's continue with RC2 and RC3. Notice here that we are linking these interfaces to OSPF version 3, but with area 4, because now we are working with area 4. Let's go for RC3. Okay, let's go for RD1 and RD2. So for RD1, some interfaces will belong to area 5 and some interfaces will belong to area 4. Notice that RD1 is facing area 4 and it is facing area 5. And let's configure RD2. Okay, now we can issue some troubleshooting commands. For instance, we are going to see what our interfaces that are participating in OSPF. Okay, show OSPF brief, and for the VRF guest, 3 interfaces, and for the users VRF, notice we have more interfaces for the users VRF because we are running IPv4 and IPv6. Notice that we have some interfaces facing the area 4 and some interfaces facing the area 0. This is because this is an IVR. We can also check out our neighbors. For instance, show OSPF version 3 neighbors. We have 4 neighbors. This is router A2, switch 3, switch 4, and router C1. And for the VRF users, we are also establishing neighborships. For VRF guests, we also have 3 neighborships. The same can be run here. So we have these interfaces participating in the global routing table. This in area 0, this one in area 4. These are my interfaces for the VRF users. 4 in IPv4 and 4 in IPv6. And for the VRF guests. We can also see the neighbors. Okay, we can also see the routing table. So for instance, if we go to router C1, show IP route, we can see a lot of OSPF routes. These are local. This is RC2, RC3, and this is RD1 that are inter-area, and these are intra-area. These come from area 0. Okay. So far so good. So we can also see the users VRF, show IP route, VRF users. But if we go to RD2, we have an error here. Gigabit 0, 0, 0 interface, gigabit 0, 0, 1000. Okay, this is wrong because we are working with area 5 here. Let's fix that. Okay. Oh. Sorry. Okay. Let's fix that. Okay. Area 5, because we are working with RD2, which is this one here. Okay, this router should not have any information in the routing table because it is separated from the backbone. So almost no routes here. Almost no route here. So we have to set up virtual link. Let's go and configure virtual link. The virtual link, the first virtual link will go from router A1 to router D1, and the second virtual link will go from router A2 to router D1. So let's go for router A1 and configure the virtual link. Remember that we can only configure it in address family IPv6. So we're going to go for the router OSPF version 3.1, then address family IPv6 for users. And that is the only address family that we have that have complete IPv6 support. And we are going to set up this virtual link. The virtual link will travel through area 4, and it is destined to this router that has this router ID, which is router D1. This one here. So let's configure now the virtual link at router A2. The virtual link is not up. So for instance, if we show OSPF version 3, VRF users, virtual links, it should be down. We have to configure the virtual link on the other side. Let's go for router A2 and configure the second virtual link. Okay, the same thing mostly. And now let's go to router D1 to configure the other side of the virtual links. So we go to the address family IPv6 VRF users and we create virtual link for router A1 and virtual link for router A2. So we have two virtual links now. It is up. It is up. Notice that in order for virtual links to work, we need global IP addresses. Remember that OSPF version 3 is heavily using IPv6 link local addresses. But in this case, for virtual links to work, we need global IP addresses. Okay, this is one virtual link with this global IP address, and this is the other virtual link with the other global IP address. So in order for this to work, I had to set up global IP addresses. So this is not enough for virtual links. You have to actually go and use a global IP address. In this case, this is the global IP address on router A1. This is the global IP address on router A2, and at router D1, let me see what interface goes downstream, 0810. I have this global IP address. So notice in the output of the virtual link, this is the IP address that I configured on the other side. This address is this address. And at router A2, for the virtual link, this address is this address. And on the other side, this address is this address. And this address is this address. So we need global IPv6 addresses in order for virtual link to work, and we need to configure that in your IPv6 address families.